So next we have Boskey, Savla, and Jared Ruckle from VMware. Hi. Um, they'll be talking about Tanzu Application Service, basically taking a bunch of the cool tools that you know out there and packaging them all together and to use to run your things in Kubernetes and otherwise. So I'll let them take it off.
Thanks so much, Tiffany. Excited to be here with everybody. I'm Jared Ruckle from the product team here at VMware Tanzu.
Hello, everybody. My name is Boskey Savla. I'm a technical marketing manager working on Tanzu at VMware.
Thanks, Boskey. Everybody probably already knows you from your fantastic performance with Craig earlier today. So that kind of brings us to what we want to talk about here today, which is really kind of go a little bit deeper into this blending of Cloud Foundry and Kubernetes, just as Tiffany alluded to from the jump. So this is all about crafting a new enterprise app platform based on all of these exciting technologies. So let's jump right into it. There's a few things that we're going to talk about here today. Next slide, please. Perfect. So there's a lot of things that open source we'll talk about here, a few things that are public betas, a few things here that are not quite commercially ready. So please take these disclaimers under advisement as we go through and talk about all this fantastic technology. All right, let's get on. Okay, cool. So why do enterprises like Cloud Foundry? If you've been at the show this week, you've heard from a few of them. You've heard from Fiserv, you've heard from Northern Trust, you've heard from BT. Cloud Foundry is all about business outcomes, getting code to production quickly, providing incredible scale, providing incredible stability for the most important applications. That's really kind of the big idea here. There's also this notion of CF push. Craig likes to call it the super highway. If you want to think about getting your laptop or you're getting your code from laptop to production, there's really nothing better than Cloud Foundry to make that happen. Also, developers are building microservices. They're using Spring Boot. They're using Spring Cloud. Turns out Cloud Foundry is pretty darn handy when it comes to running and managing all these microservices, again, at enterprise scale. And then finally, security. Every organization really has kind of a sacred duty to look after customer data, to protect their systems from bad actors out there. Cloud Foundry is pretty fantastic at that as well, with zero downtime, full stack patching, lots of fantastic security outcomes that the product has delivered. So that's kind of a great starting point and a baseline for what we have to talk about. But in the next slide, we'll see that things never sit still. Open source is always evolving. Engineers are always tinkering, always iterating. And this idea of Kubernetes has really captured everybody's attention, and really rightly so. It's a fantastic bit of technology. It's informing the foundation of what VMware is doing. It's informing the foundation of what a lot of you are doing and what your future plans are like. And so I think I've heard Kubernetes best described as a platform for building platforms. And when you think about Kubernetes through that lens and couple it together with a lot of these other really cool infrastructure projects, it starts to really take shape in that fashion. And I think, Boskey, it might be a good time to talk about how Kubernetes really forms this ideal substrate for this next generation app platform.
Yeah, definitely, Jared. So when we look at Kubernetes, I think Kubernetes is, again, it's evolving pretty fast. It's becoming very popular, or it's almost very popular. And one of the reasons why I feel like that's the case with Kubernetes is it's, although it's an infrastructure abstraction, if you think about it, but it is also very application aware at the same time. And what do I really mean by that? So if you take any application, or most applications today, many applications, apart from actually being written or coded, they when you want to deploy them in a production-ready environment, you actually have to think about so many things. For example, first of all, how do I package up my binaries in a way that the platform where it will be deployed can understand? For example, once the application has deployed, are there any runtime configurations that it needs to look at? For example, if the app needs to talk to a database service, how do we provide those services or those username, passwords, certificates at runtime? So how do we figure out managing environment configurations? Then there are resource needs that any application deployed will have in terms of CPU, memory, and the storage capacity it needs. And then once the app has been deployed, it may be a microservices app. So, how do we figure out what services are running them? So we need some kind of a service discovery, load balancing capabilities such that, the microservices can talk to each other or the apps can talk to each other. At the same time, you'll also, you want to make sure that the application is protected. It scales automatically. When there's a load, during peak hours or traffic time, you want to scale that application. You want to ensure that it's secure, by default. And then how do we handle patching and updates in a fashion, which has the least impact on the runtime of that application? And when we think about most applications, we look at various tools to deliver a lot of these. I mean, Spring itself has a great functionality where it defines some of the environment configurations or dependencies pretty easily. But then when it comes to some core infrastructure services, like how do I define what is a load balancing service and things like that, we tend to use tools that, for example, it could be Chef, Puppet, something like that, a configuration management tool that will help us mold our infrastructure just according to what our application needs. We may be talking to different cloud SDKs or APIs in order to configure these different elements that an application needs. Now, instead, what Kubernetes has done over here is it's providing a really common set of abstractions and resource objects that lets you define these application capabilities. So, for example, if I want to deploy an app, or I want to define a configuration for an application, I can take care of secrets or config maps, which is a resource object, as a logical resource object within Kubernetes. And if I want to define, services or ingress, I have similar resource objects and network policies, services defined for much of these capabilities that any application needs. From a developer's perspective, it becomes very simple rather than working, or from a DevOps team, whoever is deploying your application, it becomes very simple for them to define your application requirements in a configuration file, rather than tinkering with different SDKs, different tool sets, etc. And that is one of the reasons why Kubernetes is super popular, because what Kubernetes does is once you have defined these requirements in a config file and provided it to the Kubernetes API, Kubernetes in turn understands how to talk to the corresponding infrastructure APIs to actually provision this. Whether you're running on a Google Cloud or AWS or vSphere, doesn't really matter, because Kubernetes is going to abstract those infrastructure, and it's, on the south end, it's actually passing those, requirements in a way that that particular infrastructure really understands. So it's simplifying your development experience, your deployment experience, your application lifecycle from a very different aspects, all the way from security, provisioning, upgrades, scaling, etc. Now, at the same time, what that really means for somebody who has to run an application on Kubernetes, it also means that you have to go through a learning curve in understanding these different objects. What is a replica set? What is a service type? What is a load balancing service type? What are config maps? How do I use secrets, to store things, and how do I provision a persistent volume, things like that. So there is, number one, a learning curve in how a team can start to leverage something like Kubernetes as a platform. And secondly, once you have learned all these different objects, once you have understood the architecture of Kubernetes itself, you then have to define your application needs in really lengthy config files, right? Like the YAML files. We know how much everybody loves YAML. So just take an example, like if you have an app server or an application that is talking to a simple database service, you have to go from all the way from writing your code, figuring out how do I containerize an application, putting it into an environment, and creating a Docker file as you're running it on Kubernetes, and then finally creating some Kubernetes config files like secrets, deployments, services, etc. And the same thing you're going to repeat for your database service, right? And then finally, you get to deploy your application in Kubernetes. Now, instead, if we just layer that Kubernetes with Cloud Foundry, what we get to use is, the familiar Cloud Foundry, superhighway that Craig and Jared just spoke about. So instead of actually directly talking to Kubernetes API, we just talk to the CF API that's running on that particular Kubernetes cluster. The overall idea is to simplify what it takes to run an application on Kubernetes. From the moment it is written, from the moment it has been coded, an app has been coded, and the moment it has started actually running. So you'll see that your app, your deployment times or your time to production will considerably reduce as a result of layering Cloud Foundry on top of Kubernetes. The way I think about, when we look at Cloud Foundry on top of Kubernetes is abstracting your infrastructure, and then Cloud Foundry is abstracting Kubernetes further. Now, Jared, you want to talk a little bit more about how we do this?
And I think what you just mentioned there, Boskey, is right in line with what Craig mentioned, what James Governor from RedMonk mentioned about Kubernetes is very powerful. We need to find more abstractions, more ways to simplify that interface. That's precisely what you just outlined there. And this isn't something that just VMware is working on. This is something that open source communities are working on as well. Yeah. The Cloud Foundry Foundation has made this a really key priority. VMware engineers have made this a priority. Lots of people from the community are contributing to this to blend these two worlds together, because it is so transformational when these two worlds will be married up. So with that, we can kind of take a closer look at what's actually happening in the open source world in the next slide. So the open source project is very creatively called CF for Kates. Mind blown. So the idea here is that it's that CF developer API that Boskey outlined that you heard from customers, all week, talking about. Keeping that same developer API layer there that's proven to work really well, with marrying it up with these really powerful infrastructure projects like Kubernetes, like Istio, like Fluentd, this whole stack of things that we'll get into. But it's not just about remastering the platform just for kind of new and exciting ingredients. It's really about offering some practical benefit and upside as well. And if you think about getting an application platform like this up and running in less than 10 minutes, that's a pretty big idea. And that's what we have with CF for Kates today. Download the project, install it on your laptop, bam, you're up and going in 10 minutes. Same thing on a public cloud Kubernetes service or Tanzu Kubernetes grid on premises. No matter where you want to run Kubernetes, this is the app platform that can go with you. We also heard from Pat Gelsinger, CEO of VMware, yesterday. He's talking about VMware providing that common layer of management in private cloud, in public cloud, and at the edge. There's a lot of really exciting possibilities for an app platform at the edge. We may not all be like Phil from Blizzard Entertainment running crazy video games at scale, but still there's a lot of benefit and upside that every business is probably toying around with to put their apps closer to where their users actually are. So with that, Boskey, let's take a look at some of the components inside of CF for Kates that may look familiar to folks that know Cloud Foundry pretty well.
Yeah, so I think when CF for Kates, the open source project, started working on enabling or blending Cloud Foundry with Kubernetes, there were a couple of decisions that were taken. So one of the things is you'll see that a lot of the Cloud Foundry components or subcomponents were kind of dissected, and we containerized all these different components. In some cases, we actually containerized the code base that we already had, but then in certain cases, we actually replaced some of the subcomponents within Cloud Foundry with Cloud Native Computing Foundation native, tools. So, for example, you'll see that instead of using the Go router that Cloud Foundry used to have, we are now leveraging Istio and Envoy to route traffic into different applications that are running on top of that Kubernetes cluster. Cloud Foundry itself is going to run as a container or a set of containers and pods on top of that Kubernetes cluster. And the way we are going to deploy Cloud Foundry and Kubernetes is through a set of tools like KApp and YTD, which which simplify the overall life cycle of deploying containerized applications on top of Kubernetes. You'll also see that we're using Fluentd in order to, create a logging. We are using the default metrics server that comes with Kubernetes to store some of the application metrics. And you also see some, regular components like UAA server and this Cloud Foundry API server that has been containerized and put into that Kubernetes cluster. Now, all of the system components that we just talked about, will be placed in the namespace, and I'll get into that in the demo a little bit. But a lot of these components are going to be stored within Cloud Foundry's namespace within that Kubernetes cluster. And we'll be using a different namespace to actually stage or to actually deploy our application workloads. So on one namespace, you'll see the CF system components. You'll see things like the build packs or the Cloud Foundry, the cloud native build packs running to help Cloud Foundry automate a lot of the things that Kubernetes does. At the same time, you'll see some application workloads deployed in a different namespace.
Terrific. One last note on this slide, Boskey, go back just a quick second. Shout out to the team at VMware that recently open sourced Carvel, a suite of tools for deploying and working on top of Kubernetes. That's the K app and YTT there. You can go to carvel.dev, carvel.dev, to learn more about that. That was a project formerly known as K14s. So that's a bit of new stuff that's there that you should check out. All right, one last slide before we get to Boskey's demo. We know it's an anti-pattern to have too many slides here, so hopefully all of you are bearing with us. So we do have commercial designs on Cloud Foundry on top of Kubernetes with a flavor of the Tanzu Application Service that would run on top of Kubernetes, and it would have all of the open source goodness that Boskey just described with CF for Kates, plus a lot of the other things that you would maybe expect for a fully enterprise grade, enterprise supported version of this. So if you've used Cloud Foundry in the past commercially, or you're using Tanzu Application Service today, these things will all look very familiar, and that's our goal, is to give that familiar experience just with that exciting new extensible substrate. So with that, Boskey, I think we can move to the demo in the last 7 minutes of our time today.
Cool. So this will be pretty short. I'm going to just look at, I already have a Kubernetes cluster that I'm going to use to do this. So now that Kubernetes cluster could be anywhere, but the starting point to deploy a CF for K is a K8s cluster. And once you untar the tar file for the installer, you'll see something like this, different folders and things like that. The configuration values folder is where we want to focus our attention into. And if you look at this particular folder, you'll see there's a bunch of config files over here. The one that's called app registry values is basically, it lets you store your deployment images, etc. So when Cloud Foundry is going to deploy your application, it's going to package it up into OCI compliant container image, and it will also push it to a container registry of your choice. So you can define what that container registry looks like over here. I'm using Docker Hub, but you could use anything else like gcr.io or even Harbor. And the system registry is where we are actually going to download the components needed to deploy Cloud Foundry. So this is going to be tanzunetwork.io registry through which we are going to deploy. And then the deployment value stores very simple things like, what is my domain name that I want to use for this particular Kubernetes cluster in Cloud Foundry. So that's it. And the installation is pretty simple. I already have a Kubernetes cluster over here. And what I'm going to do is run through an installer. It will take around less than 5 minutes. So let's just do that. So I'm going to start by generating a value. So I have to define what my domain is. So I'm going to say my domain is going to be taz. And then I'm going to create this value into the deployment configuration values folder in the deployment values.yaml. So this is automatically going to generate some certificates, some values, and store it in the deployment values.yaml file over here. Once you have done that, all you have to do is run the install script with the configuration folder so that the installer knows where all our files are. And that's it. So this will take around 5 minutes. But what I've already done is I've already created a Kubernetes cluster. So I'm using Octant as you'll start seeing this cluster now popping up with all these different namespaces, and each namespace will have the components that we just spoke about. Like Octant is a Kubernetes dashboard kind of visualizer that's open source tool. It's a pretty neat tool to see what's going on within your Kubernetes cluster. So you see all these different components, these different namespaces come up like CF system, build service, etc. And within 5 minutes or 10 minutes max, you'll start to see, you'll get back a CF API. Now, I also have a different cluster where I already set up just for the purposes of this demo. So we'll just start using, that particular Kubernetes cluster. So I'm going to switch my context over here real quick. And just use the GKE S1 as my context. All right. So now if I go back to my Octant over here, it is actually going to go back to the S1 cluster. And once the actual deployment finishes, you'll see different namespaces. But let's take a look at the CF system namespace over here. And look at some of the pods. So you'll see the CF system namespace has these different, pods that we talk about, like Erini, Fluenty, the CF API server, etc. And then the CF, you also have Istio system deployed as part of the installation. And the Istio system is going to, of course, deploy Envoy and a lot of the Istio ingress gateway, the Istio pilot systems and things like that, so that we can route traffic to this particular cluster. Or actual applications within this cluster. So this is what the overall cluster would look like if you just deploy Cloud Foundry on top of Kubernetes cluster. Now, CF workloads is actually the namespace where you'll start seeing your applications pop up as you start doing a CF push. So let's take a look at that. I already have I'm using a standard pet clinic application. A lot of you must have seen this in the keynote demo today as well. But essentially, this application is going to use a SQL service. And then what I've done is, apart from defining the dependencies in the pom.xml file, created a manifest file that talks about, what that name is and where is my target file so that Cloud Foundry can start utilizing it. So I've already talked to my CF API. I'm authenticated to my CF API running on that Kubernetes cluster. So if I do a CF target, I should get to that particular space over there. So that's my API running on that Kubernetes cluster. And all I have to do to push this application code is do a CF push.
1 minute left, Boskey.
All right. What's going to happen is, in the back end, the build pack is going to take the application code, take that jar file, put it in a container, push it to my Docker hub, where that's the registry, and it will start deploying that application into the CF workloads area. So this should take around maybe a minute or so, but I think if you're lucky, it might take less than that, and I can show you. So this is all the Pacato build packs trying to create that particular build. So at the end of the deployment, what will happen is you'll have an ingress gateway. You'll have a route created using ingress, using Istio. You'll have Fluenty monitoring all the different logs coming from this particular application. And you'll have the application deployed as a pod within that Kubernetes cluster. All of this without me having to write a single YAML file, except maybe this manifest file, which is a 3-liner about what name to give to that application. So I'm saving a ton of Kubernetes config file creation in the process. All right, so the build is successful. Now, if I just go to my Docker Hub and refresh, you'll see a few seconds ago, this this image was container images was automatically created. And looks like the CF app is up. And if I go back to Octant, you'll see the Pet Clinic app deployed as a pod, along with multiple different things like stateful sets and secrets and etc. Everything, like all the resources that you see over here were automatically created by Cloud Foundry. I think that's the power
Fantastic.
of running.
Okay, well done.
Right. So we'll get back to the Q&A then.
I think so, yeah.
All right. So thank you, Jared.
See you there.
Thank you.
Nicely done.
Yep.
Thanks, Boskey and Jared. That was really cool. And especially just like seeing more of the stuff that I need to be learning for work myself. If you have any questions, just head over to the Q&A that is happening right after this, or go stick around a little bit in the Slack channel.